Okay, lesson 12.6 is on the volume of spheres. You can see we have one learning target. I can calculate the volume of a sphere. If you look below though, you'll see that the examples really incorporate more than just spheres. What we're really going to be working on is practicing either including by adding or subtracting spheres or hemispheres to other prisms and solids that we have already talked about. The volume of a sphere, the formula is 4/3 pi times the radius cubed. So if you look at example 1, you'll notice that we have a hemisphere. That, of course, is a half of a sphere. So my volume would be half of the 4/3 pi r cubed, which is 2/3 pi times my radius is 6 cubed. And if you simplify that, you should get 144 pi. Now, if you remember when we did the surface area of a hemisphere, we also had to account for the new surface that was exposed as a result of slicing the sphere in half. This is different. This is volume. The volume of half of a sphere is simply half the volume of a full sphere. In example number 2, what we have is a rectangular solid, and then we have a hemisphere, kind of like a bowl shape, cut out of this rectangular prism. So if I'm cutting out a hemisphere, mathematically that's subtracting. So I'm going to take the volume of the prism minus the volume of the hemisphere. The volume of a sphere, if you remember from earlier in this unit, is area of the base times the height of the solid. So in our case, our base is a 12 by 12 square. We can shade it in here. All right, that full base that's sitting underneath this cutout bowl, that's 12 by 12. And then the height of that solid is this 4. So if you multiply that out, you get 576. The volume of a hemisphere, well, we just did that in example 1. That's half of the volume of a sphere, which is 4/3 pi r cubed. So in our case, that's going to be 2/3 pi. The radius of our hemisphere is 3. If you simplify that, you're going to get 18 pi. These are not like terms, so I leave my answer as 576 minus 18 pi. And finally, in example number 3, we have two shapes that we're combining. If you look at this bottom shape right here, hopefully you can see that this is half of a cylinder. All right, so let's start with that. We have half the volume of a cylinder. Looks like it was sliced right down the top. And then on top, we have this shape right here. All right. That, hopefully, you can realize is half of a hemisphere. So we have half of a hemisphere. Now, unlike the example above, where we were cutting the bowl out of the prism, here I'm combining the half of the cylinder with the half of the hemisphere. I'm putting them together. That means I'm adding them. So the formula for the volume of a cylinder, well, that is area of the base times the height of the solid, but of course I have 1/2 of that this time. Right? If you picture a cylinder, right, it looks like we made a slice right down the middle here. Right? And we've kept half of that cylinder. So in our case, the base is a circle, the radius is 6, so that's going to be 1/2 pi times 6 squared. That's the base. The height of this blue cylinder is the 10. If you simplify that, you're going to get 180 pi. Now to that, we're going to add half of a, remember, hemisphere. Not half of a sphere, but this is half of a hemisphere. So I'm going to take 1/2 of 4/3 pi r cubed. If we simplify that, that would be 1/4 times 4/3 times pi. My radius is still 6. My 4's are going to cancel, so that is 1/3 pi times 6 cubed, and if you simplify that, you're going to get 72 pi. Remember, this shape right here is combining the two pieces together. We're not cutting something out. We cut half of a hemisphere, we cut half of a cylinder, and we combine them together. That's adding. These are like terms since they each have a pi, so if I add those two up, I get 252 pi. So one important thing to remember is when are you subtracting volumes? Here's an example. And when are you adding volumes? I think really important to describe the shapes you're working with to make sure you get those volume formulas correct.